So this is not basically experiment, it's basically measurement and calculation. So you're trying to see the connections between mass, mole, number of molecules, or number of particles in general, number of atoms per molecule, use of Avogadro's number. So if you have the mole, you can find the number of particles or mass. To change the number of particles, you are using Avogadro's number. Or if you have the moles and you want to find the mass, you multiply by the molar mass using periodic table. Avogadro's number is a number that is a fixed number, 6.02 times 10 to 23. And molar mass, you're using periodic table to add the atomic mass for each of the elements in the compound, in the from the molecular formula of a compound, times the number of atoms per molecule. You add them all up, you get the molar mass. So, and if you have, when you have the number of moles, you can go either to the mass or the particles or number of the atoms. Now, how could you find moles? What are different ways to find moles? Could you tell me what are the different ways? There are few ways to find moles. Add up the element AMU from periodic table, that would be molar mass, right? So that's the definition for molar mass. Add up the elements AMU from periodic table, that would be molar mass. Convert molecules, atoms, particles to moles. How would you convert molecules or atoms or particles to moles? Or grams, okay. How would you convert to moles? Caitlin, I think you're answering to Davis, completing Davis's, right? Caitlin, yes, okay. Okay, so can we put them in the complete sentence again? How do you go? How would you find number of moles? How do you calculate number of moles? One, there are a few ways. That's why I want you to write them down in a complete sentence. So one would be, if you were using the mass, how do you convert to moles? One would be mass divided by molar mass. Right? That's one. Using molar mass, use the gram per mole ratio. Yes. Gram per mole ratio, or mass divided by molar mass, which is basically the same, but using the gram per mole ratio, now that's even better because you can cancel the number you can cancel the unit. So if the mass is gram, let me do one thing. If I can, just give me 1 minute. I'm gonna try to get the surface, because every time I promise and I don't bring it, then okay. Other ways. There are a couple other formula units. Divide by Avogadro's number. Change that, please. No, that's not the definition for formula units. Formula units is the same thing as molecular formula, but is used for ionic compound. So if you say NaCl, that's the formula unit for sodium chloride, because Sodium chloride is ionic compound. You don't say it molecular formula. But formula unit is just one combination of the cation and anion. Atoms, number of particles. Yes, number of particles divided by Avogadro's number, that would give you number of moles of the atom, right? So number of atoms divided by Avogadro's number. This would give you moles of, this would give you number of moles of the atoms, right? So you have number of moles of atom is going to be number of atoms divided by Avogadro's number. So number of moles of molecules. So instead of the atoms, if you have the molecules, you get the number of molecules divided by Avogadro's number. So it depends on, you want to get the number of moles of atoms or you want to get the number of moles of molecules. If it's number of moles of molecules, it would be number of molecules or number of particles divided by the Avogadro's number. And you do the opposite to convert atoms to moles. Yes. So if you have number of moles and you want to convert to atoms, I'm reading you your comments here. You multiply by Avogadro's number, and the opposite is the opposite. Okay. If you have a solution, how do you find number of moles of solute? Let's see if I can bring the surface for you. If you have a solution, moles of solute, no, moles of solute divided by volume of the solution in liters, that would be, that is known as molarity. That is molarity, right? It's going to work. Number of moles of solution times the number of moles, multiply the number of moles of solution times number of moles of the solute. No, one more time. Molarity equals number of moles divided by volume, right? Divide by volume in liters. Now, if you want to find the number of moles, you have to rearrange that formula. So how would you rearrange it? From a solution, number of moles, if you have a solution, number of moles of solute is going to be equal to molarity times volume in liter. So number of moles of solute, molarity times volume in liter. Basically, is rearrangement of this equation here. Molarity equals number of moles divided by volume. So you have different ways to find the number of moles, but if you have number of moles, you can go from moles to particles, and particles could be atoms or would be number of atoms or molecules, right? Molecules or formula units. So from moles, you can change to particles. If you have the number of moles of element, you can find the number of atoms, because atom is the smallest unit for elements. If you have number of moles for molecular compound, then you can find the number of molecules. If you have the number of moles for ionic compound, you can find the formula units. Okay, if you have the number of moles, you can change to mass also. If you have number of moles, you can find the molarity, which is the concentration for solution as well. So you can go from moles to mass. You can go from moles to molarity. And convert the moles to molarity also. Okay, let's look at a couple of the examples here. So when you say how many formula units, basically it says how many calcium chloride, how many pieces of calcium chloride altogether. Formula unit is used for the ionic compound, as I said. So it's just number of moles times Avogadro's number. And if you express when you are completing your worksheet, please repeat the units, indicate the units, and show how you cancel the units. And do not show just the final answer. You have to show your work, how you get from the numbers. This is just a practice to make sure that after this lab, you can convert from any of these numbers, like the moles, molarities, volume, number of particles, to mass, and vice versa. So it's showing the relationship between all that. Okay, there are 14 stations. Most of them, they are straightforward. Has the mole been covered in the in lecture already? Yes. Okay. If mole has been covered in lecture, then all of them are straightforward. But still, station 9 and 13, you might have questions. Can someone tell me how would you find the answer to station 9, which is, in that station you will find the empty box, contains air. We have the density of the air. What are the steps? Could you tell me the steps for station 9? Because you want to find the nitrogen molecules from the air from the box. What would be the first step? Measure height of the box, then find the area. Okay, not the area. You are in the right track, but area is a 2 dimensions. You need a 3 dimensions. Okay, very good. So you find the volume first. So you find the volume first, and from volume, how do you find the volume? Measure the box dimensions. Okay. Perfect. So from the volume, what's the next step? From the volume, you would find the mass. How do you find the mass? I'm summarizing. I'm writing down what you're saying. Volume times density. Okay. And from that, from the density, from the mass, what do you find? Density times volume, that gives you the mass. From the mass of the, now you have the mass of the air, but you don't have the mass of nitrogen, so you have to be a little bit more specific in there. So you want to find the mass of air first. Then mass of nitrogen. How do you get the mass of nitrogen? 78%. Okay, that would be mass of air times 0.78, right? Okay, so now we have the mass of nitrogen. What's the next step? You want to convert that to put in the moles. How do you go from mass of nitrogen to moles? And the nitrogen is going to be N2. So you want to find the moles of N2. For moles of N2, mass of N2, which is the mass of nitrogen, divide by 28, right? 28 gram per mole, of nitrogen. So when you have the moles of nitrogen, fourteen times 2, yes, or 28 gram per mole, okay? From moles of nitrogen, your next step, and I think that would be the final step, right? You want to go to the number, and that is the particles or number of N2. Number of N2 molecules would be moles. Moles of N2 times Avogadro's number. Okay, so I have the steps. Actually, I collected the steps that you told me what to do in each step. You're going from the first, you want to find the volume. That's the, as you said, length times width times height. You change to the mass of the air. In order to change to the mass of the air, you multiply the volume by density. You're welcome. So in the parenthesis, I say how to convert it. And then the arrow is the next step. From the mass of the air, you go to mass of nitrogen first, because mass of nitrogen is different from mass of air. That's only 78%. So you multiply by 0.78. You get the moles of, then you convert to moles of N2. Moles of N2, it would be mass of N2 divided by 28 gram per mole, because it's looking for number of molecules of nitrogen, not atoms of nitrogen. If it was atoms of nitrogen, you would multiply by 2. This number would be by 2, or you divide the mass by 14. Then you get the number of moles of nitrogen atom, not nitrogen molecule. So it depends. You're looking for moles of nitrogen molecule or nitrogen atoms. That determines to use 14 or to use 28. And to find the molecules, when you have the moles, then Avogadro's number is going to help you. You can copy the steps if you like from the chat area. Okay, and then what about 13? What's 13? So 11, if you know already 9 for a number 11, since the volume is given, so you know that volume needs to go to mass first. So density is provided. You can calculate that before. And then is asking for number of carbon, number of atoms of carbon. So when you find number of molecules of propanol, then you need to multiply by 3 in order to get the number of carbon atoms. So because per molecule you have 3 carbon atoms. Basically being able to count or practicing the ratio or subscripts and the coefficients and all that. Any questions about 13 or 14? Uh, 13, okay, just molarity and the percent composition. In the solution, you find a sample of the table, salt. We have the chemical formula, and you're going to add 6 grams of that into 100 milliliter. You are going to raise it to 100 milliliter. The mass for that is going to be different than 100. Is not 100 gram. When you have 100 milliliter of a solution, it could be 100 gram if the density is 1 gram per milliliter, but you need the mass of the compound, the solution. If you have the mass of the solution, then you would give the 6 grams of NaCl, divide by the total mass, which is the mass of the solution. And when you watch the video, it gives you, I don't know exactly, is it 105 or 106, and you have to record the exact number from the video, times 100. So mass of NaCl divided by mass of solution, which is the NaCl plus the water, times 100%, that gives you the percent. And to find the molarity, what are the steps to find the molarity? Just to make sure. What are the steps to find the molarity for question number 13? Let me finish just part of the 13. Sure, Lilian, I will go over 14, question 14, definitely. So how do you find the molarity of the solution for question number 13? Molarity equals, if you write the formula, okay, molarity equals moles divided by volume. Make sure to say volume in liter. Molarity is number of moles divided by volume in liter. So if you want to find the molarity, you need number of moles. Okay, so it makes it easier when you look at the formula. You find, how do you find number of moles? You already have 6 grams of NaCl. You divide that by 58.5 gram per mole. That gives you the number of moles, right? And then volume is 100 milliliter. You divide that by 1, or you multiply by 1 liter. So if you're using the dimensional analysis, 1 liter over 1,000 milliliters. But you have 2 steps. So first you change the gram of NaCl to moles of NaCl. Oops, mole did not spell correctly. Sorry. So grams divided by and the volume is going to be 0.1 liter. So in order to find the molarity, you would say number of moles divided by volume in liter, which is the 0.1. We're asked to find the molar mass of a compound. Do we use the mass from the periodic table? Yes, exactly. If you're looking for the molar mass, you use the AMU value from the periodic table. And when you have the periodic table with the 2 decimal place, that's the maximum decimal places you would use. Or when I work the problem on the board, usually I don't remember the decimal places. I use everything as a whole number, except for chlorine, because chlorine is a 0.45 to decimal points, and I just rounded up to 0.5. Otherwise, the calculation is going to be off. Like for molar mass of NaCl, Na is 23 from periodic table, and Cl is 35.5. So when we add the 2, it's going to be 58.5. That's the number of grams per each mole of NaCl. Good questions. Okay. Question number 14 that was asked question number 14. You find 400 milliliter of 0.5 molar aqueous solution of calcium chloride. So what would be the first step? You're asked to find number of you're asked to find the mass of the solute. In order to find mass of the solute, what are the different or molar? What would be your first step? If you have the volume and you have molarity, from the volume and molarity, you can find number of moles. And if you have number of moles, you can go to mass, you can go to particles. Okay, so your first step would be to find number of moles. So in order to find number of moles in question 14, you say to find the number of moles from a solution, it would be, we had it already in the chat if you look at it. So this is the moles of calcium chloride, CaCl2, equals molarity times volume. And you want to make sure the volume is in liters. Moles of molarity times volume in liters. So if you have the moles, now going to mass, it would be easy, right? How do you go from moles to mass for calcium chloride? You would use the gram per mole ratio, which you are, in this case, you're going to multiply by the molar mass. So mass of calcium chloride of Cl2, it would be moles times calcium is 40, and that is 7,111 gram per 1 mole calcium chloride. So in order to find the mass, when we are asking to find grams, we use the periodic table values. Yes, exactly. If you have the number of moles already, you would use the periodic table to find the AMU for each atom, and you add them all up, like I did now for calcium chloride, because I need the molar mass for calcium chloride. Calcium is 40, and chlorine is 35.5 times 2, that would be 71. 71 plus 40, that's 111 gram per 1 mole of calcium chloride. Very good, Hannah. Yes. Okay. Any other questions you might have? The rest is like additional. You do have some additional questions, I believe. So with the 14 station, you get the data from the procedure and from the video. And for additional questions, this data is given already. These are just questions like you would get in your lecture. Please pay attention to the units. So if it says atoms of PB, is just asking, this one is straightforward. And this is argon. It's not a typo. It's argon, AR, argon. And I want to see if there is anything complicated, which it's not. No, these are simple. One step. Okay. I'm sure if you have questions, you would tell me, right? Any questions? No questions? Okay. Perfect. Okay, gonna call for attendance, so you can go ahead, collect your data for the from the experiment for your calculation. Hannah, this is for attendance.
Here.
Hannah, yes, thank you. Sahar, Sonia, Ashley, thank you. Leah, Caitlin, Jennifer,
Here.
thank you. Correct. Gareth, sorry. Carmen, Danielle, Davis, Caden, Shruti, Kate, Bianca, Manisha,
Here.
thank you. Jada, Jose, Sierra, Javier, Lillian, Aisha, Matthew, and Ria. Very good, perfect. Okay, if you have any questions, you may stay to ask your questions. If you don't have questions, please watch the video to collect your data for the calculation, and have a nice day. Thank you. Thank you so much.
Professor, I have a question.
Sure.
When it comes to when you name the elements and you put the Roman numerals, is that for all the what's it called, transition metals?
Yes, anything that has multiple charges. So if you have like copper could be 1 or it could be 2, or iron could be 2 or 3. So you want to indicate which copper or iron you're talking about. So if it's FeCl2, because we know that chlorine is 1 minus, and since it takes 2 chlorine to cancel the charge for Fe, so Fe must have been Fe2 plus in this case. So is a Fe2 plus. That's how we know is the charge. And since we also have a FeCl3, we cannot have 2 compounds with the same name. So we cannot say FeCl2 as an iron chloride and FeCl3 also as iron chloride. So we indicate the charge, which iron we are talking about. Is it iron 2 chloride or iron 3 chloride? There are limited number of these, and your professor should say which ones he or she wants you to memorize, and if it's like just the tin, lead, iron, and copper, or like also they want you to memorize for chromium and cobalt and everything else. So, or later on, you should be able to calculate the oxidation number. Then you can also mention that. But that's just a short list. So you just memorize iron could be 2 or 3, lead could be 2 or 4. Then you have to indicate it, and that's only for transition metals, as you said. Very good, because representative metals, they don't have multiple charges. They are they follow their ideal noble gas, and they gain or lose electron to reach the electron configuration of the noble gas in the same row, if it's a non-metal, or if it's a metal, the previous
The
row.
alkali earth metals and
Yes.
yeah.
So whichever is the closest in the number. So if, let's say, argon is 18, and then you have if you have a atom with atomic number 16, like oxygen, is gaining 2 electrons, but potassium with atomic number 19 is going to lose 1 electron. So it should be like less than 3. To lose or to gain. So you always find the closest noble gas in the number, not the distance in the periodic table. So when you're looking for the closest noble gas, look for the number and not the location. That's going to help you.
And do I really have to memorize the charges of those, or can I just like if I see Cl2 and I know that's a -2 charge, could I figure it out that way, or do you think I should still memorize them?
You don't have to memorize it. You can figure it out. But if like the question is different, if they say like ferric, yes, yes, Bianca, you're yes, the unit is correct for molar mass, which is the mass for 1 mole. So going back to Johanna, let's say if they tell you what's the formula for ferric chloride, then at that point there's no really hope that you cannot say how many chlorine. First, you need to know what ferric is before you can put like a trichloride, because ferric is for higher number, and ferrous would be for lower number. So if it says ferrous chloride, then we know is the FeCl2. Ferric chloride, it would be for FeCl3. Or ferric is higher, and then plumbic, that would be for lead-2 and lead-4. If, depends on your professor, depends on your lecture professor, if they are not using the common name or classic nomenclature, using of ik and us, then you should be fine with converting or calculating the charges from the counterpart. So if you have like trichloride, then that means is a 3+, and you are in the right track. I mean, you should survive like 99% of the time. There was just 1% that they're giving you the name, like the classic name, and you're trying to find what the charge was. Your question, Bianca, it's how to change the grams to AMU. So when you take the number, when the number is sitting in periodic table, is expressed in AMU, as soon as you take it out of the periodic table, you change the AMU to gram. So AMU is the mass per atom, but a gram is the mass per mole. So that's the relationship. Okay, gram per mole is for gram per mole. That is the unit for molar mass. How do you convert gram to AMU? Not sure I understand. So AMU and gram, they are basically saying the same thing, But when it's sitting in the periodic table, because it's like one atom, the mass is expressed in AMU. So you just cross the AMU and you put G. That gives, like you were asking, like you were trying to find the mass for oxygen, which is O2. One oxygen is 16 AMU. That when you say one oxygen atom, but you know how small is that? So you have to use the atomic mass unit for that. That's the AMU. One oxygen atom weighs 16 AMU, but two oxygen atom would be 2 times 16. That's 32. Okay, that's 32 AMU. But 1 mole of oxygen is going to be 32 gram. 1 mole of oxygen, which is Avogadro's number of molecules of O2, which is a huge number of molecules of O2, that would be 32 gram. So when you want to express in the working numbers in the lab, they're always in gram. AMU is more of a theoretical value or number of particles that it's hard to work with. So the way I say it, I say when it's sitting in the periodic table is AMU. As soon as you take it out, you bring it to scale, it's going to change to gram, because you cannot measure AMU using what we have in the lab.
Thank you, Professor. Have a great day.
Thank you for the good questions. Okay, any other questions? Carmen, do you have any questions?
Thank you, Professor. I'm gonna.
You're welcome.
The lab.
You're welcome, Hannah.
Have a
I'm
nice
glad.
day.
Thank you. I'm glad you asked the questions. And if you have any other questions, please let me know.
Of course.
You're welcome, Carmen. I was just doing if you have questions. Okay.